Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So today on the bench I have a Technics SA-500 receiver. Very nice vintage receiver. It's very nice condition. It looks good. I don't think this is a veneer. I don't think it's solid wood. It might be solid wood. Yeah, you know what? It's hard to tell. But it is. No, maybe it is a veneer. But it looks good. And it's got some nice features too. It has a power display, power level for both channels, left and right. It has a tuning strength meter and a center tuning for the FM stations. 2 tape monitors with record dubbing for both. FM muting, loudness. It's got bass and treble controls, and it's got low and high filters, but it also has boost low and high. This is unusual. I've never seen that before. You can cut the lows and highs by flipping them down, or you can boost the lows or highs by flipping them up. It's kind of like a loudness button, which, yeah, this does have a loudness button, but this is kind of unique. I like that. Balance control, rotary selector for AM, FM, phono auxiliary, volume control, and the tuning knob has a nice feel to it. It's got a nice scale here. It looks like it's transparent. It's got a few layers here. You have the outside glass, and then a transparent piece of glass inside with the graphics on it, and then you have your dial scale in behind all that. Got some switches here for the power display. You can either have it running it on or off. Turn it off if you want to see the flashing LEDs. And then you have 2 ranges for those meters, and then 2 switches for your remotes and main speakers. So this is a client unit, and it's been sitting here for a long time, so I apologize for that. I have to get caught up on my work. This little note he left me, it says right channel quiet. Warm white LEDs. He's thinking about putting some warm whites in here. I can do that. That's easy. FM tuner seems intermittent. Okay, and then recap. Well, I can tell you right now, if this is got those crappy Mashishita caps in there, they're probably all puked all over the board and leaking. It's going to get recapped anyways. But it says loudness sounds off, or sorry, loudness off sounds very thin. So he's definitely having some troubles getting the audio through the path there. Let's try it out. I got it hooked up to a set of speakers. Let's try this on auxiliary for now. Everything's set up correctly. Turning it on. And here's our tone. That's the left. Okay. Now, I changed my tone from 1000 Hertz to 440. A lot of people are complaining about the tone. 1000 Hertz seems to bother a lot of people. 440 is more of a natural tone. I think that's, what note is that? I think that's A note or something. I don't know. I'm not a musician. But right off the bat, I can hear left channel going. Right channel silent. Okay. But I have it on fully left right now. There's the right channel. You can barely hear it. It is very quiet. Now, I'm getting some scratchiness on this pot, and it's coming through the right channel fairly well. So I think the power amplifier is working. It's just in the preamplifier, I think, is where everything's getting shunted. See, I can get crackles and pops out of the right speaker just by twisting this, which tells me everything's working beyond the balance control and the volume pot and all that. Everything's working, but it's probably something in the earlier stages. That doesn't sound good at all. You can hear that right in the right channel. Okay. Drawing 27 watts. Which is about right, I guess. Base. It's a really noisy pot. That one's clean. Oh, there's our right channel. So obviously this switch is buggered. Okay. Tape monitors. And those LEDs are so... These LEDs are so dim I can barely read them. So we might have to replace some of those LEDs. They're really, really dim. They are on, and as I turn it up you can see them progressing, but they're just not there as far as light output. Okay, let's try phono stage. I'm getting some noise out of the left channel. Quite a bit of noise out of the left channel. Right side silent. A little bit of hum. So we might have a problem in the phono stage too. Might have a dead stage. You should be able to hear some kind of hissing and amplifier noise, but it's very quiet on the right. Okay, let's turn this down. FM. Don't have an antenna hooked up. Seems to be working okay. It's got no antenna, so it's pulling in stations. Turn the muting off.
Move it up to 10.
Seems like it's working. AM.
Based on the individual in film, the bill is being met with optimism.
Everything seems okay on AM and FM.
For want of a better word.
Alright, looks like we got a little challenge ahead of us. We got some dirty switches. This one here is cutting out the right channel. Dirty pots. Might have a dead phono stage. We still... doesn't sound good out of either or both of these channels. Might have bad caps in them, so I'm assuming we do. Let's have a look at the back. So we got our antenna inputs, 75 ohm unbalanced, 300 ohm balanced AM antenna. If you want to add a long wire, I believe there's a bar antenna built inside already. Phono auxiliary, 2 tape loops. Okay, and then we have speaker protection fuses, 5 amp both. I'm going to check those, make sure they're correct. And then we have our 2 sets of speaker outputs with these twist locks. I don't know, these aren't, they work. Not the biggest fan of them, but I think, oh, maybe they're, yeah, they got a range of twist to them. They're all good. Problem with these things is you get little strands of copper wire stuck in them, and then they kind of clog up inside, so I'm gonna have to check and make sure that they're all clean inside. And then we have 2 courtesy outlets, 2 courtesy outlets for switched and unswitched, which is good. Okay, it does have the groove on each side, and it runs in this track. Now this cover, it seems the screen has a puncture in it, like somebody stabbed it with a screwdriver or something. It's got a hole in the screen. You can see that. Can't really see it on top. I'll try and straighten that out. Alright, and here we are. Okay, so I got it unplugged. Transformer on the left. Got our mains fuses here. Mains wiring exposed, so you see your hazards right here. 2 big filter caps held in place by this cover. I don't know what purpose that cover serves. To hold the cap steady, I guess. Amplifier and power supply section right here. This is all power supply section down here, it looks like. Here's a bridge rectifier, a couple of regulator transistors, some tired looking caps, and then we have our power amplifier. Hey, you know what? Actually, that is all power amplifier here. I made a mistake. Some of the power supply is back here, but this here is all amplifier. So we got a right and left channel. Two massive heat sinks, or one massive heat sinks they're sharing. TO3 devices. Everything on the right is tuner. Like I said, here's a AM bar, and then our front end. Everything looks looks good, nice and clean. Don't see anything, maybe a little bit of smoke staining, but everything looks pretty good. It's dust free. Looks like it was well kept. I'll turn it around and you can see there's a board in here. I don't know what that does. I think that is probably tone amplifier. Maybe that's the preamp there. And then still more front end of the power amplifier down below here. And lighting we're using for lamps. Oh, it's already got LEDs installed, so that solves that problem. Let me just check these other ones. Looks like somebody's worked on this and put LEDs in. Yep, they have LEDs installed. Okay, well, that solves one problem. Make sure they're all working good. So somebody's definitely been in here, done some cleaning, because naturally it wouldn't be this clean. And we'll go through, I think it desperately needs a recap. I can see, let's see here, I don't see any leaking ones yet. There's bound to be green fuzz on some of these legs. If I look, okay, we'll get into that. Somebody's definitely been in here because there was some missing screws. There's a missing screw here, there's two here missing. So I'm just going to go through. It's got like a fiberboard bottom. I'm not a big fan of these. I'd rather see the steel for the shielding, but they do have some shielding here over some of the sensitive circuitry. I'd like to see that fully covered. But looking at the bottom, everything looks nice. Nice and clean. Don't see anything jumping out at me right now. Do I need to remove this screen? I guess I might as well. This aside. Okay. Where to start? So what I'm going to do is I'm going to remove all the front panel knobs, the fascia, everything, because we're going to have to get into these pots and switches. A number of them were quite dirty and intermittent. So let's just pull this all apart. It's all going to need a cleaning in behind the glass here too. It looks kind of smoky and dirty, and we're going to have to address those LEDs. So let's might as well just take it all apart now. So when you remove the bottom 4 screws for that screen, it also attaches the heatsink to the main board through this connector, these 2 connectors, and it just comes out as a unit. It's nice for servicing. It's got the original semiconductors in there. It's got it looks like one of these emitter resistors is kind of cooked, but that could be something. Could be something or nothing, you don't know. I'll test those And the soldering on this, I'm impressed. The soldering on this looks really good. There's no cracks on any of these joints, and I don't think it's ever been touched from the factory. Just a little dirty, and we'll put some new heatsink compound on those devices. Doesn't look like anybody's ever been in here. Let me check some of these. Sometimes they are loose. No, they're all doing good. They're all good. So we'll deal with that in a bit. Looking at these caps, the first one out, it tests absolutely fine. 100 microfarad, it's coming out at 96, and 540 milliohms ESR. Not too bad, but it would be irresponsible for me to leave these caps in place because these are notorious for leaking. And like I said, I haven't seen any leaking ones yet, but it's just a matter of time with these caps. This one looks like a really low hours unit. I don't see a lot of heat stains or anything like that on the board. All the solder connections for these are all good. Everything looks really good here. Looks like a lower hours unit. So I'm just going to go through and change caps for now, and I'll bring you back in when there's something to show you. I still, let's see here, where is the display for the power meters? I need to deal with this. And that's all hidden under here, so I might have to disassemble some of this stuff going on. Okay, if I remove this little board here with the fuses, it reveals underneath, it reveals the protection circuit. There's a relay, and there's a little bit of dust on this because I don't think anybody's been in here before, and some sad looking caps in there too, so we're going to have to address all that underneath. There's 4 caps that I can see, and the relay itself, we'll have to remove that relay and check contact resistance, but it's really difficult to get in here. Yeah, we'll figure it out. It's a little struggle, but we'll get it. What is that thing? Is that a crimp? Interesting. Somebody made a splice here. That doesn't look factory, or maybe it is. It's got these crimps here too. Is Panasonic using crimps in their mains wiring? It's hard to say. This would be secondary going to the board. The 2 orange wires are secondary, so okay. They're probably just extending the, yeah, I see them all over. They're extending the transformer wires. The transformers they got didn't have long enough wires, so they had to make do with it. But I see them everywhere. Maybe somebody replaced this transformer. So here's an example of some weirdness I'm finding. Have a look at this. It'll focus. Oh, come on. 220 microfarad bipolar capacitor. How are you ever supposed to find a replacement for this? And this thing tests out at 300 and some odd microfarads. It's way out of tolerance. I'd like to replace it. What do I replace it with? Do I take 2 470s back to back? I don't know. Like, that is some strange stuff there. I've never seen a 220 microfarad bipolar. So I'll see what I can do for this. Mesh Ashita cap, especially made probably for this application. Who knows? But that's in the protect circuit down in the bottom here. So with 2 470s back to back, I'm getting 210 microfarad on my meter. ESR is actually lower than the original. ESR comes out at 445 milliohms, and you know, I think that's going to have to do for the time being. Well, we'll put this in. I'll clean up this connection here and heat shrink it, and then I'll put it in. So 4 caps into it, and I already find my first leaky one. So I expect they're going to find some more. And this one actually tests really good. It tests like a brand new cap. 100 microfarad at 10 volts. Good value, good ESR, but leaking. So it's got to go. Okay, so I'm done a recap, and it went really well. I was pleased with this. This Technics is pretty easy to work on. You have full access on the main board here and the tuner board from below, so no problem there whatsoever. I did have to remove a strut that was across here in order to get these caps down in this corner here. They were blocked by this metal strut, so I removed that strut and I have to put it back. Few notes. The board is not really marked well with regards to positive or negative. It is marked, but you really have to look for the mark. Like, for example, I don't know if you can see this. It's C632, and then there's a little negative beside it, and that's the negative stripe for the cap. But this is a pretty easy one to recap, because if you notice, all of the negatives on all of the caps are facing the same direction. And if you look through each and every one of them, they're all pointed towards the front of the unit on this board. But on this board, they're all pointed backwards to the back. So if you look, you see all the negative stripes pointing towards the back. And that makes it easier for me to orientate them and put them in. But it all went well, yeah. And I'm really impressed with some of the build quality of this Technics. Like, for example, here in the tone section, it's all film caps in the tone section, and there's no electrolytics, which is good. So everything's pretty good that way. Just have some dirty switches to deal with. Here is the Phonos equalization stage, and it uses 2 chips, one for each channel, and it also uses these goofy couplets. It looks like Technics is using quite a few of these in this receiver, and I see them all over the place. Here's another one, and then there's these ones here that look like resistor networks, but they're actually some kind of they're marked as an IC, and they're probably some little internal circuit with surface mount resistors and caps and whatnot. So yeah, if we have a trouble with any of these parts, it's going to be no fix. But other than that, I'm really pleased with the build quality of this thing. This is also a very low hours unit, and just looking at the main amplifier, it's really, nothing's cooked here. Everything was good. No cooked capacitors, but there were some that were starting to fail, and there are some that failed. So here's a look at all the caps I took out. And I'll go through and figure out the percentage of what failed in that pile, but there is some fails, and but they're all gone now, and it's all fixed up. Next step is I want to deal with this power meter display, these LEDs on here. I'm going to have to see if I can find something. It's a unique setup. You can see the LEDs, the wires, and then they're bent back, and these LEDs are kind of sitting on their back. You can see them there. There's what, 8 or 9 of them. And I'll have to figure out a solution for this, because I'll never be able to find these LEDs anywhere. This is vintage 70s tech. I did find a date code on here. It's 1978. All right, let's have a look at this relay. Place your bets now. I'm going to open and close the contacts, and we're going to see how badly the relay is for resistance. Okay, so you should be able to see the meter there. We've got 24 volts in the power supply. Let's turn this relay on. Look at that, 9.2 volt, or 2 ohms. That's not good at all. It gets worse as 12 ohms, 13. Yeah, this is 20 ohms. That relay is not doing very good. Let's try the other side. You got one here. Okay. even worse. Okay, let's clean this up and then we'll retest because this relay is not doing too good. All right. Okay, here it is. No contacts on top, only contacts, and they look pretty black. Let's have a look at this. Take the spring out. And let's remove the just oxidized, that's all. You have a good look at it. See the contacts here, pretty gray, and these ones are pretty much black. They're not pitted, they're just oxidized. Let's have a good look here. Yeah, they're actually pretty good shape. Okay, let's give these contacts a polish and we'll see how it improves. Alright, so I wanted to use, for this repair, I wanted to use a polish, Brasso. Everybody recommends Brasso. And I thought I had some in the garage, but I went and looked just now and I can't find it. So I don't know if I don't have it or if it got thrown away or if it's just lost in the void. But I'm going to use another polish. I think all polishes are pretty much the same. They're just a really fine grit abrasive in a paste form that you can use, rub it on, and it works, removes the oxide coating. So I'm just going to use the Novus scratch remover. This is for plastics, but today we're going to use it on silver. And the big thing with these polishes is you have to remove the residue because we don't know what's in the polish itself. So I'm just going to give this a polish here. And it just strips off the oxide layer. And you can see that. There's quite a difference now. I think that one's done. Let's try this one. You see all the black oxide coming off on the swab. I think this is going to do a good job here. We're going to clean it well after. Okay, let's get another. Just want a small amount. I don't need much. Just want to clean. Let's just bend these up a little bit. Get us some working room. We'll bend them back down when we're done. Okay, now we got full. I've never done this before, so it's just an experiment on my part. Looking good. But anything, any kind of polish will remove that oxide coating. It's not, silver oxide is not a hard coating to remove. It just needs to be scrubbed away. I think that's good. Alright, so we got everything looking good. Let's get some alcohol and clean this well. This is 99%. Now it's not important that it's shiny, it's just important that it's clean and free of oxide. Okay, that should do it. Okay, let's bend this back down. There's no contacts in these holes. It's just a stopper for the armature. Okay, let's put this back together. And our spring. Everything lines up. Okay. Let's test it again. We need this one and this one. Place your bets. Let's see what it turns out. Oh, look at that. 7 milliohms. That actually works pretty good. And it's consistent. I'm happy with that. That is a very good result. Let's try the other side. Seven milliohms. So yeah, I'm really pleased with that result. How does this go together again? I think... No, it goes this way. Okay. I think that was a success. Look at the crap it pulled off. This black stuff. All the oxides. So, I'll put that back in. I'll clean up the outside. It's a little dirty. Oh, look, it's the regulator circuit. Alright, here's a look at the power output meter. I replaced all of these LEDs. What do we have? Like 11 of them? There's all these. They're very dim. These old LEDs, I don't know. They don't... I'm sure they weren't that dim when they were new, but I don't know. There's something wrong with the epoxy on this too, because it's kind of turns to... It's not even a yellow anymore. It's kind of a brown mud. So the epoxy's changing color and fading. This green was really dim too. You couldn't see it. You could barely see it. In a dark room you could probably see it. The reds were bad. So I replaced them all with 3mm LEDs. Now I had to drill out these holes to accept the 3mm LED because these are a little bit thinner. But it all works out, and I think it's going to look good when it's completed. So everything's done here. Recapping's done. Relay's done. What I need to do next is switches and pots. And I want to remove the bass treble and balance. And probably the volume knob too. It looks like somebody's had the volume pot out. You can see from the soldering on the back of the board. Looks like somebody's been at it with a soldering iron. So I want to do all the switches and pots and make sure I get that loudness switch because that was the worst offender. So I'll make sure I do that next, and then pretty much wrapped up. And then we're going to do some testing. So I took out the volume pot, and remember when I said it looked like somebody was playing with it before? Well, this is not the original pot for the stereo. So this pin here is broken off. I don't know if you can see that. Usually when they put these on a printed circuit board, they'll fold over two of the legs so that it stays put, so that they can go through the wave soldering process and not fall over or fall out. And then sometimes when you lift those legs to straighten them, to pull them off the board, they snap. That's what this looks like. But I didn't see, they had it soldered, but I don't know if there was a connection there. Another thing is, this thing started its life as a splined pot, and then somebody took a file and made it into a D pot. Now, the volume knob itself is for a D shaped, it's not splined, so that fits in there now. Problem is, this is not the knob is, I don't know, you can see that knob, how it doesn't track properly. It's kind of wobbly. Plus we have more problems here. See how this is bent? And looks like somebody cranked on it this way. Yeah, that is not straight at all. Look at that. So I'm going to straighten that out. Here's the other side. Here's from the side. Looks pretty straight that way. So I'm wondering, can I just take some pliers here? Where to grab it? I grab it right here. I think I don't want to grab it on threads. Just push it back in. I think that's a little better. Yeah, it's got, I don't know. Let me try opening this. We can take the thing apart. We'll take it, disassemble it, and we'll straighten everything out. Okay. Alright, we're not going to disassemble this because it's crimped on this end. Oh, looks good. Okay, I'll put that cap back on. It doesn't do me any good. And I'll treat this pot, even though it wasn't making much noise. I didn't notice. And I'm going to try and straighten this some more. That needs to be pushed back in. I don't know if I can do this. I can't. I can't remove this collar with the threaded collar on it without disassembling this. So there's no point in me taking this apart any further. I'm going to oil the shaft, try and straighten this out a little better, and let's see how this tracks now. I don't think it's... I don't think it will ever track properly because this D is not putting the knob off center. So I'm just going to leave it, try and straighten it so it doesn't look like it's wobbling. And we'll put it all back together after I treat it. So my fix for these pots when the lug breaks off like that is I just I'll tack on a piece of wire and then feed it through the hole. Don't rely on the solder to touch on the tip here and make a bond. It won't, or it'll crack. So you got to have a wire going through the hole. So okay, I had to remove the dial scale and the glass and the meters and everything in order to do the pots and switches. That was my choice, and doing so I upset the dial cord, so it's a little pissed off at me right now, but we're going to put this all back together. But first I think we're going to need to remove this side, and I think it's just a matter of 2 screws, and then it just slides forward, I think. Let's take this screw out, and this one. Yeah, it just slides forward and out. Okay, that'll give me room to do the dial cord here. Okay, I'm going to give this a try. There is a sequence, if you look in the service manual, on the very last page, there's a diagram and a sequence in which you do this. And we're fortunate here because the string's not cut. I'm going to reuse the old string, and I'm just going to put it back on all the pulleys and we'll be finished. But if you have to, let's say your dial string is broken or cut or missing, they have instructions on what to do there. You make a cord 200 centimeters in length, and then you prepare it, and you do go through all the steps. But we're going to just go through the steps of restringing this. I'll put the diagram up on the screen so you can kind of follow along. So first step is we start with this innermost string here that's anchored to the spring. And that's our first step. So we go from here. Well, first step actually is closing the tuning capacitor so it's fully closed. And then you have your drum with your strings coming out the top here. So this is our first step. It's a half wrap around the drum. And then we go down to, I believe it's this pulley here that's hiding underneath. And then we go to this pulley here, which is going to change the angle for us. And then we go to the dial pointer. And since our capacitor is fully closed, our dial pointer is going to be on the low end of the band. And then we pull the remainder of the string through on this pulley at the far left. Back again. I've got some wires in the way here. Alright. Now this is where it gets kind of tricky. You want to give it 3 wraps around the tuning knob, starting from underneath, going around clockwise. 1, 2, 3. And then we go down to this pulley here, pulling it taut, and then the rest of this is just a matter of putting this back on the drum. So we got 1 wrap, and we got 2 wraps. Now, the spring should give us our tension, but right now the spring is completely collapsed. So if I go around, can you see this? No, you can't. If I go around and just pop the string back on, we are done. Okay, so aside from some wires being in the way, oh, you know what? I'll have to address that. Okay, but it's back in and it's working. So let's go through its range of movement in both directions. One thing you could do is you could take these little screws out and put a little dab of synthetic grease on each of these pulleys, and that would make it spin a lot faster. I also re-oiled the bearings in this tuning knob, so it has a nice feel to it. But I think I might end up, I think it's pretty good. I'm just going to go through the range of motion here a few times. It's slipping. Why is it slipping? Is it caught on something? I do have 3 wraps on there. Maybe I need 4. It says 3 wraps. It shows 3 wraps on the diagram. It doesn't say it. What is binding here? Something's binding. Just wondering if it's... Okay. I wonder if I give it another wrap. Let's try another wrap on this. I'll take this off. Okay. Got this here. Put 1 more wrap on. Got 4 wraps now. I hope the string is going to be long enough. Okay, let's put this on. Come on. Cooperate. Okay. It's a lot tighter. I think this is a lot easier with a knob. Okay. It's not slipping anymore. You want to check that the lines aren't crossed on the drum. You want them to be laying beside each other, not on top of each other. And as it wraps around, it's going to follow and not get caught up on the one below it or the one above it. Okay, so that's working. And I have 4 wraps on there, which isn't quite a bit of spring pulled out. Go through a few more times. Seems to be working. Alright, filter capacitors. These are 10,000 at 50 volts. Not much to say about them. I don't think they have date codes on these. But anyways, I pulled them out, tested both of them. One tests out at about 9,500 microfarads, which is pretty good. The other one tests down around 8,200, so it's quite a bit less. So I'm going to replace both of these with brand new 10,000 microfarad at 50 volts. These have probably, well, they do have different pin spacing, so I'm probably going to end up having to drill a hole in the board here to get it to accommodate. But that's no problem because there's a lot of real estate here and there's a lot of empty space. I can drill a hole, and they just won't be perfectly lined up. They might be a little offset by one another, but that doesn't matter. Okay, the new caps are installed. Now that I have smaller caps, this bracket is really redundant. This bracket that held attaches on the back panel and right here, and it encompasses those 2 caps. It doesn't really do anything anymore other than strengthen the back panel, which it doesn't really need. But I took advantage of using this screw hole to make a cover for all the mains voltage stuff, and this is just insulating card. It's a plastic, I don't know what plastic it is, but it's thick and it's rigid, and it will hold, be good cover for protecting the mains voltage. So I'm going to go with that instead. If you need to service it, you can just flip it up, and there's your fuses. But okay, we're all back together, and I think it's time to do amplifier setup. Now, Technics made this really simple for us. It put the 2 test points right on top of this printed circuit board here, and they're right up high, and you just clip your leads to them. We're looking for 8 millivolts, and this is across 1 resistor, so let's clip that on there for now. And they want 5 minutes warm-up time before we adjust, so I'll turn it on, and let's do our first power up. We shot up to 90 watts and settled back down around 26, 27 watts on the input. And we'll just let this go over 5 minutes. I think while we're waiting for this to warm up, let's just test our DC offset on our output. Let's see if I can get a reading here somewhere. So this will be, let's see here. This will be the right channel. And we got about 4 millivolts floating around between 0 and 5 millivolts, which is pretty good. Let's do the other side, if I can see it. And this side's hovering right around 0, which is both pretty good. I'm not complaining about that at all. Looks like we got a nice healthy amplifier here. Alright, it's been on for about 10 minutes. The rate channel, I think this is the rate channel, I'm not sure. Looks good. I'm not going to adjust that. Let's try the other channel. And that's looking perfect too. I'm going to leave that alone. And we are consuming 27.9, 27.8, somewhere around there. Yeah, it's not even warm. Pretty good. Alright, so here's a look at how it's working. This is the AM band. Notice the display is nice and bright now. You can actually use it. AM's working great.
Our home buying process and get you pre-approved. We want you to leave our office feeling confident and ready to buy your first. And then they'll also tell you a story, or you read a story.
You know what that awful noise is in the background? It's not on that station, so it must be interference.
20 to 40 kilometers an hour. Overnight tonight, another warm one. We'll be dropping near 15 degrees with variable clouds.
So yeah, wait, AM's working great. Let's try FM. FM's working good too. I don't see anything wrong with the FM. I got it on mute. That station I never pick up.
Il a dit à un moment donné qu'il va.
New this year, we've added
Some stereo action here.
Enter to win a $1,000 gift certificate.
Muting's
to Mr.
working.
Lou.
Working as predicted. Pulls them in good. I got no complaints with this tuner. There is quite a bit of background noise here. Some weak stations. Get farther up the band, it gets better.
But to do that in this, it's stupid.
Still getting a lot of background noise. Don't really have a great antenna, it's just a piece of wire.
we'd move mountain.
That one's coming in clean. And that one's working good. It's the strongest station here. And it's all working good. I think I might have to do a little bit of a dial alignment because it is out a little bit. Yeah, we're out a little bit. Might be out a megahertz or so. So I'm going to tune that up. We are wired in for a power test. I have my 8 ohm load. Scope hooked up. Scope is hooked up, yes. I have my voltmeter hooked up as well. And we're feeding a 440 hertz tone. And let's see here. You can hear it's going on right now. Shut the speakers off, and we can bring this up and do our power test. Now, we have clipping on the left channel, which is the top, way before the right channel. So that tells me there's an imbalance in this channel. So let's hit the balance control centered. There's a little bit right there is probably, that's centered. So we are getting a clipping on the top. So let's turn this down a bit till the clipping stops. Right there, I think. And we have 23.55 volts RMS on the output, and then I'll just let this go for a while. We are supposed to get 55 watts per channel at 8 ohms, and I think we're beyond that. 58 watts per channel at 1 kilohertz, 0.04% total harmonic distortion. So it's doing pretty good. I'm going to let this cook for a while, and then I'll come back when it's full power. This thing's barely warm. It's not heating up. Okay, we are at the 10-minute mark, and this is just starting to get warm. Starting to get hot now. It's to the point where I can't keep my hand on it because it's right at that point. And we're at 10-minute mark, and this is what we've been consuming, 235 watts. So I think that is a success. Let's turn this down. Now, I'm not overly concerned about the channel imbalance because I've done this before where I've recapped receivers or amplifiers, and then when you power them up for the first time they have a wild imbalance. But then after a few weeks of use, it seems to balance itself out. It's like the caps need to settle into their new positions, and I think that's the case here too. But then on this one, I do know there's this volume potentiometer that somebody's replaced it's got some problems. So I don't know if that potentiometer is bad or what, but I'm going to give this a listening test, and I'm going to see how it goes with everything. Let's try some square waves. Let's try right now. Let's try this, and we will turn it. We don't want full power. Right about there is good. Let's see what we can do here. So we have bass cut, bass boost, and centered, treble cut, treble boost. It's actually doing a really good square wave. Now here are the boost and cut switches for bass. It's bass boost, bass cut, treble boost, treble cut. I like those switches. It's nice to have balance, control, everything's working, and then we have our loudness. Okay, so let's take up the frequency. I'm at 440 right now. Let's go up to 1000. Okay, there's 1000. Two, three, four, five. 4, 5. Right there's 5. It's doing pretty good. Turn this down a bit. Get a little imbalance there on the top channel, and let's try this treble control. That is set for 0. Yeah, okay. 5 kilohertz square wave looks pretty good. Let's go up 6, 7, 8, 9, 10. Still looking good. Not a bad square wave, up to 24 kilohertz. Starting to get some, take it down and get 20 kilohertz, 20 kilohertz right there. You see we have a little bit of difference between the channels. Little bit of difference. So make note of that. But otherwise, it's working good. Alright, just going through and doing some tuner alignment here. I went through the AM alignments and made some huge gains on the AM performance. I wasn't expecting that. But I'm going through the FM right now and I'm only making minimal gains. It was already peaked up as high as it was going to go. I'm really not doing anything here. But I just wanted to show you, I'm just on the stage here where I'm doing the distortion alignment. Let's see here if you can read that. The FM mono distortion alignment. And what you do is you feed in a tone through a carrier and pick it up through the tuner. And you set the discriminator core to give minimum distortion. And the spec for this right now is right here. I'm doing 1000 hertz tone. Is 0.15% distortion. And 6 kilohertz is 0.3. You could do the 6 kilohertz, but I'm set up right now for 1 kilohertz at 100 megahertz. I got a strong signal, minus 50 dBm. You get a nice, clean, strong signal, and the distortion is actually less than specified. It is down around 0.1413. So this is really good. Shell tells me that we got a nice healthy tuner here. It's calibrated, it's tuned in, and it's working good. So let's try a 6 kilohertz tone. I'll set this up for 6 kilohertz, and we'll turn this to 6 kilohertz. 6 kilohertz right there. Okay. And we have to, there's our tone. Turn that down, and let's set this up. I'm going to zero this out, and then hit distortion. And we are reading probably around 0.27, so it's still less than advertised, and looking good, All right, here's a look at the bad caps. So I did some tallying and some measuring. These ones on the left have failed. Now, but what I mean by failed is they're out of tolerance by more than 20%, or their ESR is more than double what it should be. So that's this pile here, and that is actually 37% of the capacitors, almost 38%. These ones test out fine as far as electrically. Now, leaking is another matter. I separated them into two piles, one leaking, one not leaking, and the pile of capacitors that have leaked was 16.9%, almost 17%. Now, these capacitors are in really good shape for their age, because this receiver is really low hours. Now I feel if somebody put this receiver back in service with these old caps, they would start puking all over the board. Once they start heating up and going through the thermal cycling of heating up, cooling down, heating up, cooling down, they would start to leak. Right now they're not leaking bad because they sat in dormant state for quite a while, and whatever did leak out of them is just, you know, a little bit here and there. You can see a little bit of corrosion on the leads, but I think when you put these caps back in action, they would start to leak a lot more. I think this is a good plan for this receiver, is to do a full recap, and I don't see any argument for keeping old caps like this in a receiver, because they're only going to lead to future problems as far as I'm concerned. So get them out, get fresh ones in, and enjoy the piece of equipment. Well, there it is. It's done. I don't know if I have much more to add to this. The basic takeaway from this one was old caps these old LEDs that weren't lighting up anymore. They were really dim. Really, really dim. So I got that mounting and everything's good. So this one's going to go back to the owner. And but first I'm going to give it a couple weeks trial on my listening bench. I'm going to have a good time listening to this one. I think this is a pretty good receiver. I'm pretty impressed by the build quality, and I'm also impressed by its condition. It was well taken care of. So yeah, this is going to be a good one. I'm going to enjoy listening to this one for the next couple weeks, and then on to the next. All right, well, thanks for watching, and take care, and we'll see you on the next one.